I'm going to explain about moment generating function examples. As you discussed, MGF means it is an averaging process for random variable. Just it is an average for random variables. But in the special case, for example, if you take one company data, so in the first day, one company is designing 10 mobiles, and the second day they are designing 15 mobiles. In the third day, they are designing just assumption it is 25 mobiles. So like this, if the data is varied like exponential. So then what is an average? So by using MGF, we can calculate the average. So just assume that this is an e power mathematical equivalent is e power tx. Then the MGF is denoted with mx of t is equal exponential of e power tx, also denoted with e power tx is equal minus infinite to plus infinite e power tx f of x dx, f of x dx. This is the continuous random variable average. For continuous random variable, this is an average for random variable x. If we take discrete random variable, so mx of t can be defined as, that is sigma I is equal 1 to n e power tx into p of x. So this is for discrete random variable average. So we'll go with one example anyhow. So here we can see this the same thing. So, but if you take m1, the first main we know that already. That is e of x is equal integral of, for continuous random variable, x into f of x dx. But here the difference is, if the data is varied exponentially, so therefore it can be written as minus infinite to plus infinite e power tx into f of x dx. So that is the difference between first mean and highest mean, or else mx of t. This then one more name is, it is a also called as highest moment in the special case. So we'll go with one example. Here you can see this. If the density function f of x, density function f of x is equal to x from the limits 0 to 1, then find MGF. So according to MGF, moment generating function average, so can be written as, it is a continuous random variable. So in university exams, they are asking the questions on continuous random variable. From minus infinite to plus infinite e power tx multiplied with f of x dx, f of x dx. So substitute the limits are given from 1 to 0 to 1, and f of x means x, and multiplied with e power tx dx, e power tx dx. So let assume that this is an u, x is u, and uv formula. So let x equal to u equal to x, u equal to x. Then u dash means dou by dou x of derivative of x is equal to derivative of x is 1. Similarly, let v equal to e power tx by t, I am assuming. Then v dash means integration of e power tx is equal e power tx by t. Now, what is an UV formula? UV, integral of UV equal UV dash minus integral of U dash V dash. So now we can do it here. U means x, V dash means integration of e power tx. You can see this, integration of e power tx. So that is equal e power tx by t of the limits are from 0 to 1 minus integral of 0 to 1 u dash. Here you can see this u dash. U dash means 1, x dash, derivative of x1. Again v dash, e power tx by integration of e power tx by t dx. Therefore, so now we can see this, that is substitute the limit 1 into e power tx e power tx by t minus 0 x place in the place of x need to substitute 0 0 into something 0. So first term completed, then go for second term. Again e power tx by t integration is e power tx by t into t square. The limits are from 0 to 1. Substitute the limit again, e power tx by t minus, substitute the e power t by t square, e power t by t square, minus of minus plus, e power 0 is 1, e power 0 is 1, 1 by t square. That's it. So like this we can calculate the average for a moment generating function. Thank you.